Hi, everybody, and welcome back. We only have a couple more lessons to go this year. That's kind of exciting. So today we're going to talk about how to solve systems of equations by substitution. All right, last class we talked about how to solve them using by graphing. And basically what you did is you took two equations, you graphed them, and then you found the point where they crossed. Well, sometimes that point is a decimal, or you can't figure it out by looking at the graph, or it's just easier to solve algebraically. So today we're going to look at the first type of solving algebraically, which is substitution. And with this, we are going to, there we go. So solving systems by substitution. So with this, we're not going to use a graph. All right, but keep in mind, if you're stuck, you might be able to. All right, so these are the steps for substitution. First, you're going to need one equation to say either x equals or y equals, as long as you have one of them alone. So you want either the x alone or the y alone. And it doesn't matter if it's on the left or right-hand side. Next, you're going to substitute this expression into the other equation. All right, so if x equals 5, wherever you would see a 5 in the other equation, you would plug, or wherever you saw an x in the other equation, you would plug a 5 in, and so on. You're going to solve the new equation for the missing variable that's still there, and once you find your answer, so if you find what x equals or y equals, you're going to substitute that into the easier equation and solve. So let's go through this step by step. So the first thing we want to do is you want an equation that says either x equals or y equals. All right. Right here, this one says y equals. Right, so y is the same as negative 5x plus 13. So basically what we're going to do, like if I told you y was 5, wherever I saw a y, I'd plug in 5. Well, I'm telling you y is equal to this. So wherever I see a y in the other equation, we're going to substitute it in. All right, so again, you need one equation to say either x equals or y equals, and then you're going to substitute that, whatever it's equal to, that expression into the other equation. So I'm going to rewrite that top equation, but instead of 4x minus 2 times y, we're going to do 2 times this whole thing. And it's important that we put it in parentheses because we need to distribute that negative 2 through. Okay, so all we did there is I took this top equation, but instead of writing 2 times y, I wrote 2 times negative 5x plus 13 because that's what it's equal to. Okay? All right. So now what you've done is you've made it so there's only one variable, and we can easily solve that. Going back to unit 1. All right, I see parentheses, so I need to distribute. Be careful, though, because you're not just looking at a 2 times. You're looking at a negative 2 that you're distributing. So we'll bring the 4x down. Negative 2 times negative 5x would be positive 10x. Negative 2 times 13, negative 26, equals 16. Next, combine your x's. I see a 4x plus 10x, 14x minus 26, equals 16. Add 26 to both sides. 14x equals 42. Divide by 14. And if you don't know it, it's 3, but if you're not sure, you have a calculator here to help you. All right, so 42 divided by 14, 3. All right, so now you found what x equals. We also need to know what y equals. All right, because in the end, remember, what you're dealing with, both of those equations are equations of lines. You're looking for this point. So we solved the new equation for the missing variable, and now we're going to substitute our answer into the easier equation and solve to find the other variable. So we already know x, now we're going to figure out what y is. So if you look at these two equations, they would both give you the same value for y when you plug x in. But let's take a look at this bottom equation. If I just plugged 3 in for x, I could easily determine y. If I plugged it in the top equation, I would have to still do some solving. All right, so we know that x is 3. So I'm going to plug it in for x in this equation. Again, it doesn't matter which equation. That one's just easier. So we have y equals, we know that x is 3. So instead of negative 5 times x, we're going to do negative 5 times 3 plus 13. Negative 15 plus 13 is negative 2. So if we were going through and graphing these, you would have had to solve this one for y, find the slope and y-intercept, graph them, find the point where they cross. Here's the x and y value for where they cross. So if we really were plotting these two lines, this point would be the point 3, negative 2. That's your solution. Okay, so let's just try a couple more. I know it seems complicated, but the more you do, the easier it'll get. Some people don't like substitution, but it is easier, and there is another method that I think some of you will like better. All right, in the next one, I see x equals. It's the same as this. So I'm going to take the x out of the other equation, and think about it. If I have a substitute, you don't see me. My substitute's here. Well, I'm going to substitute this 5y minus 11 in for x. We're not going to see the x anymore. It's going to be replaced by that. So instead of 3 times x, we're going to do 3 times 5y minus 11, because that's what x is equal to. And then rewrite the rest, plus 3y equals 39. And is it always the bottom being substituted in? No, that's just how it's working out because the bottom equation is already solved. So again, all we did is we took out the x right here, and we replaced it with this 5y minus 11. Okay, so now we can solve. So 3 times 5y, 15y. 3 times negative 11, negative 33. Plus 3y equals 39. Just keep bringing everything down. Next, we'll combine our like terms. 15y plus 3y is 18y. Minus 33 equals 39. Next, we want to add 33 to both sides. And again, if you're not sure, use your calculator. 72 though. So we have 39 plus 33, 72. And then we need to divide both sides by 18. So divided by 18. 4. So y equals 4. But don't forget, we need to figure out what the x value is that goes with it. All right, because when you have a point, you need the x and the y value. You need both of those. So look at your top two equations. It looks like this bottom one's a little easier because it already has x by itself. So now that I know that y is 4, I can figure out what x is. It's 5 times 4 minus 11. 20 minus 11 is 9. So if this were a point on the graph, remember every single point is an x and then a y, so it would be the point 9, 4. If you would take the time to graph those. Now with this one, they're already solved for y, so we could quickly look to see if we can see the equation, or see the graph. 2x plus 5, and then negative 3x minus 10. If you started with a minus sign, it wouldn't work out. Okay, if it's the first sign, it's negative. If it's in the middle, it's a minus. So we look at the graph. It looks like maybe the point -3, -1. Remember, a quick way to do it is to use your calc right here. So you hit second calc, choose intersect, choice 5, enter, 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 -3, -1. All right, so that's the point where they would cross if we were doing it graphically. So that's exactly what we should end up with. All right, but sometimes they'll specify you have to, solve by substitution. Well, if you notice, they both say y equals. So if they both are equal to y, then they're both equal to each other. So why don't I plug this? Instead of writing y equals, we'll set them equal to each other. 2x plus 5 equals -3x minus 10. Again, if they're both equal to the same thing, this is actually the transitive property you'll learn more about later on, then they're equal to each other, right? It's like having 2 5s is equal to $10. 10 1s is equal to $10. 2 5s is still equal to 10 1s. It's the same value. All right, so we'll solve it. I got to combine my x's. There's no parentheses to deal with this time. Since it has to go to the other side of the equation and it's a minus, we're going to have to add it to make it disappear. 2x plus 3x is 5x, plus 5 equals -10. Don't lose that negative sign. Subtract 5 from both sides. 5x equals -15. Divide by 5. X is -3. And then again, pick one of them. Why don't we go with the top one this time? So we have y equals 2x plus 5. Well, we just found out that x is -3. So y is equal to 2 times -3 plus 5. -6 plus 5 is -1. Which again, look at the point. It would be the point -3, -1. All right, you would have got the same thing if you plugged it in here. -3 times -3 is +9, and 9 minus 10 is -1. All right, the only other type, and actually I wouldn't even use substitution for this one, but I'll show you how you could. It doesn't say x or y equals. So it would be easy for us to make this bottom equation equal to y if we just subtracted this 8x over. So you can't actually use substitution right off the bat here because it's not in the right form. And you can write that as y equals 48 minus 8x or -8x plus 48. Either way, you have to make it so it says y equals first. And again, if this were me, I would use the new method you're going to learn tomorrow for something like this. But now that you have y equal to something, now you can take that and plug it in for y up here. So we'd still have the 2x, but instead of +4 times y, we'd have +4 times this. And again, make sure it goes in parentheses. So all you're doing is you're taking this equation, but you're taking out the y and replacing it with 48 minus 8x because that's what you determined it to be equal to in the bottom equation. All right, so then we'll distribute 2x plus 4 times 48. Let's do some math in here. 4 times 48. Oops. 4 times 48. Let's try that again. 192. 4 times -8x, -32x equals 42. All right, let's combine these. 2 minus 32 will be -30x plus 192 equals 42. We'll subtract 192 from both sides. And you may notice that's -150, but if not, you've got your calculator right here. Right, so we have 42 minus 192, -150, like I said. So -30x equals -150. Divide both sides by -30. And again, if you're not sure, use your calculator, but you're going to get 5, not 50, just plain old 5 for x. All right, now plug it into one of the equations. Doesn't matter which one. Why don't we plug it into the bottom? And we want to use one of the originals. So we have 8x plus y is equal to 48. We know that x is 5. So we have 8 times 5 plus y equals 48. That's 40. And then to get y by itself, we'd have to subtract 40. So y would be equal to 8. And if you were graphing those two equations, they would cross at the point 5, 8. Because remember, it's always x, y. So that's substitution. All right, tomorrow we'll talk about elimination. But in the meantime, I want you to get some practice in. You'll notice these all say either y equals or x equals somewhere. All right, those both say it, so you can set them equal to each other. So give those a try. Remember, whatever y is equal to, substitute it in for y in the other equation. So you got 5 examples to try, and then we'll do our last couple lessons here to finish up the year. If you have any questions, stop by the Math Lab. I'd be happy to help you out. Have a good day.